Well, good afternoon, everyone, and welcome to our Monday afternoon webinar, High Precision Additive Manufacturing for Product Innovation. My name is Rob Romanowski. I'm the Director of Sales Operations for 3HTI, and joining me today, our hosts, or additional hosts, will be Gary Hoffman, who is the Vice President of Sales and Principal for 3HTI, Bruce Bodnick, Senior Technical Director for 3HTI, and a very special guest, Peter Denmark, the Director of Sales for the Americas from EnvisionTech. And what we're going to do today is we are going to review the EnvisionTech product line and also have an overview of the many different materials that they have that are available to print, which is over 70 different types of materials, which is very exciting. And these printers are absolutely give the highest resolution of any other 3D printer in the industry. So what I'm going to do now is I'm going to pass everything over to Peter Denmark. If anybody has any questions, feel free to type those in. We'll try to answer them as we go. And we will also have a live streaming camera of one of the EnvisionTech printers that Bruce Bodnick will give an overview on in a little bit. So with that, take it away, Peter.
Well, thank you very much, Rob. I appreciate it. Thank you, 3HTI, and for inviting me, and everybody online listening. I appreciate it. We're going to talk a little bit about 3D printing today from EnvisionTech.
Hey, Peter, real quick.
I hope everybody's
what you'll call it. The screen that I'm seeing is a double screen. It's showing your current slide and next slide. You may want to choose your other screen.
Oh, computer froze.
Hate when that happens. So while Peter's figuring this out, rather quickly, I know he'll probably go over this, but one of the most interesting things about EnvisionTech as a company is they started in a couple of markets that had a need for high precision results, specifically hearing aid and jewelry manufacturing. So that's one of the reasons with that focus when they entered the market, it's the main reason why all of their printers have the best resolution of any on the market today. So Peter, I am seeing seeing the appropriate screen.
Everyone see that well enough now?
Yes.
All right. So this is EnvisionTech, and as we talked about, we are 15 years. We are 15 years in manufacturing in 3D printing, so there's a wealth of experience. This is our CEO on the left, Mr. Al Tablani, and our CTO, Sasha. And we started in 2002 with the commercialization of the DLP printer. So that's digital light projection. So, and you see in that picture on the top is a projector that was used to produce a UV light onto a photocurable resin. So it was the first ever of its time, and that's what gave high accuracy, high detail, was the ability to control the pixels within the projector. That's some of the software that EnvisionTech came up with 15 years ago. So we have a long runway ahead of us or behind us as far as where we got in our software development. We'll talk a little bit more about that as we go through, but we really focused on three key markets: the medical, the professional, and the industrial. We do have one of the third largest install base with about 5,000 machines globally. And this has been adopted into manufacturing for digital manufacturing due to the reliability of the machines. It's very easy. It's a projector. It's a light turning on and off. It also has a speed factor to it as well, because we're able to produce the entire image at one frame, and that allows us to control the intensity and the burn-in of that light to the photocurable resin. So we have a little bit more we can do at the different wavelengths. Just to show you that we are a global company, we have offices in Dearborn, our corporate headquarters office. I'm located here in Woburn at one of our other companies, Viridis. We have Gladbeck, Germany, Kiev, where we do a lot of our software. Our materials is done in Montreal, and manufacturing is done both in Germany and California. One of the things that EnvisionTech really is experienced with, and now with the support of 3HTI, we have outstanding support. Our machines are very reliable and are very durable, but as machines go, they do need some support sometimes, and we offer that kind of white glove service from EnvisionTech and through the extended partner of 3HTI. The 6 distinct technologies that EnvisionTech has are the bioprinting. This is something that was very big in Europe when it started in 2002, has now reaching a fever pitch here in the United States as far as the adoption of bioprinting due to the kind of cultural norms we have going on now. Very exciting part of EnvisionTech. It is the global leader in this, over 200 published articles on the bioprinter as one technology. The DLP is where EnvisionTech got started. We have many different size machines in the digital light projection. To get the scale we needed for the larger parts, we needed the 3SP technology. We'll go into that a little bit further in detail. And then we have our speed machine, which is our CDLM, and that stands for Continuous Digital Light Manufacturing. Top right, you have our binder jetting system, which is the RAM system, and that is robotic additive manufacturing. We have an ADB robot with a head effector on it that has inkjet cards in it that lays down sands and a binder, creating molds and cores for the foundry industry. The last technology we have is the SLCOM, and that is sheet lamination. So it stands for Selective Lamination Composite Object Manufacturing. This is a machine that will be doing carbon fiber and polycarbonates, a fiberglass and polycarbonate, and a carbon fiber with a prefrag of thermoplastics. To get a little bit more specific on the detail of the EnvisionTech technology, is a lot of this technology started with the DLP, and if you notice in the top right over here, we have a great white paper on the advanced DLP that only EnvisionTech has. The speed, which is very important when you start digitally manufacturing, EnvisionTech has a consistent advantage over that as far as being able to project the entire image on the vat at one time to be able to cure in one entire layer, and that also adds to the accuracy and surface quality. So the surface quality is the best in the industry. You won't see stair-stepping effect. You won't see the ridges from step to step. You'll see a nice smooth contour, and a lot of that is due to the pixel shifting in the ERM, which we explain here in this slide. Again, there's a great white paper to go into more detail on this, but basically what's happening is we're pixel shifting half a step to be able to neutralize the stair-stepping effect through the technology of the ERM. This allows for smoother, faster parts. And then speed, we came into the technology in 2006 with the patent being filed. A lot of people say, how are you like carbon? It's more, how is carbon like EnvisionTech? We have a 15-year head start on the software and materials for that technology. And due to this technology and growing technologies is the ability to modify materials for specific applications needed in the manufacturing world. EnvisionTech is a small enough and big enough but nimble enough company to be able to create materials for a solution for a problem. EnvisionTech likes to be a solutions provider. When we move to the 3SP, that stands for Scan, Skin, Spin, and Selectively Photocure. Again, top right, we have a nice white paper. I think that's something that maybe we'll send out after the webinar if everyone's interested in that. But this is basically taking an SLA and making a better mousetrap. What we've done is taken a dual cavity diode laser and mounted it to a gantry that slides over the X and Y, so we would increase your throughput. With the standard SLA laser, you're standing in one direction, bouncing off expensive galvo mirrors, to hit a spot for milliseconds, to where we have a light curtain that goes across the photocurable resin in one pass. And that ability to scan and actually selectively photocure allows us to have large build areas with the surface quality for large parts and a growing number of materials. Here's a little bit more of the internal systems of the USP. You see the laser assembly that will drive over the build area right here. So if we have any more questions about the technology, happy to take those. We can talk about those now or at the end. Want to talk about the markets that EnvisionTech's in with the sub-markets. So obviously medical is a very big part for 3D printing, high customization for customized patient care. We have a number of materials that are already FDA certified. They are in multiple machines and multiple technologies. Bioprinting, we are the global leader there. In dental, we have a commanding market share as far as all things that touch the mouth, whether it be suck down retainer models, whether it be crown and bridge. Really, we touch every part of dental. Hearing aid devices is where EnvisionTech kind of made its mark in the digital manufacturing space. We have over 100 machines at one customer producing over 600,000 unique parts every month for the hearing aid industry. And then for the professional market, we break it down: jewelry, entertainment, and education. For jewelry, EnvisionTech is pretty much known as the Coca-Cola. It's a very, very high market share due to the high accuracy, high detail, and number of materials. The accuracy and detail needed in jewelry has now been replicated to many other MCAD type applications, to where we have materials that can be lost, cast, waxed, process. We have high temperature materials for molding, over molding, vacuum forming, blow molding. We have many different materials that are done that way that have developed from jewelry. Entertainment, again, for stop animation, the high detail, the ability for the materials to be painted or post-processed. And then in education, that's where we're seeing a really big breakthrough now, as a lot of the educational institutions are partnering and agreeing with the technology of EnvisionTech as the future. So we're getting some of the younger people introduced to the machines and material. And then this is where kind of I live most every day, is in the industrial space, in the aerospace and automotive. Due to the size and the material choices of the EnvisionTech machines, we can touch automotive and aerospace. With some of our other machines, we're getting into the prototyping and low volume. Ability of the materials to withstand some of the heat and pressure that a traditional engineered plastic would do. We are getting very close, and we feel that we're there in a few applications. And then we have the Viridis machine for the foundry industry. Extremely exciting, very revolutionary type product, as far as the first ever commercialized robot doing 3D printing in customer sites. So extremely exciting technology. This is just kind of some of the customers that EnvisionTech has already and growing. Just wanted to pick a few out in each one of those to show you some of the people that we're working with. I'm not sure if everybody has been to the EnvisionTech website, but the website under case studies is really a great page to learn more about what other applications are being digitally manufactured. We have a machine at Facebook that's creating a lot of the prototyping and possibly end-use products for nascent objects. It's a really neat application that EnvisionTech conquered with materials and machines. The hearing aid is the big one that we've done. We've had a lot of break-offs as far as the loop and a Sarnova. Do we have time to watch a quick video? I don't know if this will work, but I'd really love to show a video. Do we have time, Rob?
Yeah, absolutely.
See if this will. Is that playing?
the largest healthcare provider in the world. From this facility, we serve Kona and Unicorn brands. There's over 500 employees. It's a lean manufacturing facility. At Sonoma, we envision a world where everyone has the ability to just live a normal life, even if they have a hearing impairment, because of the kind of products we supply. What we produce here just isn't a product, it isn't rigid, but it's an individual custom-made item that someone is going to wear on their body, and it's going to make a huge difference in their life. And this all ties into the technology that we use to produce that. Together with EnvisionTech, we collaborated quite intensively to bring this cutting-edge DLP technology into the on-demand manufacturing rapid prototyping process, and we've done that successfully. This is truly cutting edge because we're producing all of our products by 3D printing.
We needed to ensure that when we went 100% digital manufacturing, that we had a process that was easy to use and operate and produce very consistent shells.
We have over 100 EnvisionTech printers across the globe. We produce over 1 million shells a year. Each shell is customized for each patient. We've been using the EnvisionTech machines, I believe, almost 15 years, and it's been a very, very successful experience for us.
We are able to build, brew, and wrap material colors in one printer, and it helps our process to flow much better.
We have completely transformed the way custom hearings are made today. Our customers, the hearing healthcare professionals, are going to take a silicone impression of their customer's ear. That impression then is sent in to us with a set of order instructions for what kind of hearing aid they want. That impression is then scanned so we can capture that digital image. The digital image is then moved to a modeler. The modeler now is designing not only the shell or the part that's going to fit in the ear, but they're laying out all the components inside that hearing instrument. We pass that then into what we call our shell lab. That's where our EnvisionTech 3D printers are. A build is created. The digital printer simply forms that shell. When that's finished, we pull out parts for that instrument, and in production, they take that custom-made 3D printed shell. They take the electronics, they take those together and seal that. After that is completed, it passes through a couple of different QC steps, including a full electroacoustic testing. And once it passes all that, it's ready to ship out to our hearing healthcare professional and customer, who then fits that on the actual user of the device. I'm very proud that we were the first to believe in that technology, because we believe that this will be the cutting edge, the greatest and the best and transformational way of doing it. The products we provide to people are really making a difference in their life every day. So being a hearing aid is a big deal. And EnvisionTech technology is the standard in our industry. So the patients feel better. They're getting smaller hearing aids that are retained in the ear better, that last longer, that have cosmetic appearance that's acceptable to them. It's a great cause to help people improve their hearing. And that's what we do. We help people hear better and live the life without limitations.
Nope. All right, everyone. Just want to thank you for listening to that. It's pretty amazing what has been able to do and transform an entire industry over to digital manufacturing in 500 days. It was quite an accomplishment, and it's ever growing. Now, kind of get down to like the nuts and bolts and the meat and potatoes of this is printers and materials. So we have a Manufactur 4 LED. This is what is being used at Sarnova. This is what's being adopted widely for digital manufacturing. The LED light allows for 20,000 hours of print time. So it's a very highly reliable light source that is allowing us to increase our development in different chemicals and different resins. This is our E-Shore material. It's an E-Shore A value of 40 to 50, 60 to 70, or 80 of 90. We can do different durometers of that. We think it is very highly different than what the competitors have because it is waterproof and tear resistant. It's very much like a polyurethane material. And we're very excited to have that on our machines now because we think that's going to lead to many more applications. The CDLM, I think this is, again, going to add to the toolbox of customers that are looking to digitally manufacture products for mass customization. The speed of this allows us to grow parts at a rate that has never been seen before from EnvisionTech, and this is going to definitely transform a lot of how products are being made. We have many of these in the field now, and we have very high customer satisfaction on this because of the ability of no separation. So when this is growing, there's no separation forces, so you have very fine detail and a lot less need for supporting of it. And also, too, in the clear materials, you have a very ultra clear, almost full transparent type material that is very highly sought after in many medical applications and many other areas. The 3SP, I think one of the biggest applications we have is the eTool 2.0, ability to make injection molded tools to get design verification or product verification faster, quicker, easier. And also, too, our partnership with Somos has really developed a great material as far as for prototyping and for casting. It is a durable material. It's a very sturdy material for prototyping, and then also, too, you use certain softwares, Tetris shelling, you can actually make this a castable part. So 3SP line has the ability to scale in, as far as number of machines or as far as size of machines. Materials is a big part of EnvisionTech and of all 3D printing. EnvisionTech was ranked number 2 in number of materials available. We do have over 70 different materials for all of our different machines. Some of the high detail, high accuracy parts are the RC9 materials. We also have an E-shell black, an E-shell white. It's a very true white and a very true black. So if people are looking for specific prototyping in that or looking for end product use in that, we do have those materials available. We do have the HTM 140, which is a high temperature material for castings or overmolding. And then on the 3SP, we do have E-Clear, E-Model, some ABS-like materials for applications that demand ABS material. We'll talk a little bit about the IP. There's about 140 patents pending or granted. A lot revolve around the DLP and the CDLM technology. That is the ability to use the grayscaling, and that's the pixel shifting. There's a lot of developments that we have patented that we think are going to be suiting us well in the future. And then other things are the 3SP patents and key various patents as far as motion control. A lot of the materials in that, in both of those machines are proprietary to EnvisionTech. And our last video is right here.
Printing has a dream. And sure, making cool stuff is part of it. But the dream is much bigger than that. So much bigger. 3D printing is about transforming manufacturing, making it faster, smarter, and more efficient. Eliminating waste and design limitations and expensive tools that preventers from taking risks. 3D printing makes sure everybody gets a chance to make their idea a reality. A lot of people talk about the dream, but at EnvisionTech, we've been delivering it for 15 years as the top 3D technology for mass customized hearing aids, paving the way for digital dentistry and bioprinting technology for advancements in medical research. We commercialized the first robotic 3D printing. At EnvisionTech, we've been pretty quiet about our leadership in 3D printing. That's because we've been pretty busy delivering the 3D printed dream.
All right. Well, that's all from my side. Hope everybody had a chance to listen. And if you had any questions, feel free to shoot them at me.
Sure. We one question came in. They want to know if we can share the overview of the presentation. And
Sure.
a comment saying that this is an excellent overview of the EnvisionTech products.
Sure. Yeah, I'll work on a cleaned up document.
Excellent. So I think if anybody has any questions, please type those in. At this time, I think what I'm going to do is I'm going to pass this over to Bruce, but we do have a couple other questions. Can you or have you printed any type of football helmet?
Football helmets? I don't know per se. I know we have done baby helmets.
For medical?
Not football. For medical.
Yeah.
Like the cranial helmets for babies for unique shapes on their head.
Mm-hmm.
I don't think football helmets.
Yeah.
I mean, it's possible to print. We can print football helmets. Not a.
Yeah, there's probably a lot of I guess standards that would go into printing a football helmet, even if it was for a youth football for a youth football league. So a couple more questions coming in. What is the build size on a 3SP?
There are 3 different size 3SPs right now. They are the Vector, the Extreme, and the Exceed. All the technical data is definitely on the website, but your Vector, you're looking at a 12 by 8 by 8. A Extreme, you're looking at like a 14 by 12 by 10, and then an Exceed, you're 18 cubed.
Cool. Next question. Have you printed any leg compression devices? And I don't know if we need more detail on that.
Leg compression, as far as prosthetics? Yes, we have printed prosthetics. I don't know what compression is.
Yeah, I'm not sure either. If you want to clarify that question, we can get back to it. Can the printing support variable durometers throughout the structure?
Depending on the machine, depending on the material, we have done different durometers in hearing aids from base to tip.
As far as leg compression, the question was clarified. For leg compression as used in hospitals, like in beds.
No, I don't think so. Now, there's some people using 3D printing for casts. We haven't done that. but that's a compression cast. But EnvisionTech hasn't done that.
Understood. On the 3SP machine, for molds and injection molding, what kind of temperate restraints are there?
So we had a third-party university verify the parameters for injection molding. We can share those all with you, but you're looking at temperatures between 300 and 400 degrees.
Mm-hmm.
On our current version of E-model, we are constantly trying to chase the higher heat deflection. But right now we're between the 3 and 350. So polypropylene, you can get about 50 shots out of it. ABS, which is a little bit higher, you're going to get maybe 25 shots out of it. And one customer did Ultim at 1 shot, and it survived. And he got one article off of the press, and that was enough for him to justify using the machine.
When you say 350, you mean 350 Fahrenheit.
Correct.
Next question. What type of slicing software does EnvisionTech use?
So we use a Magic-based for factory suite. So if you're used to using Magic, it's very easy. We have our proprietary per factory suite that you'd use pretty much like a driver from that, or you can use the support generation system in the per factory.
Okay. How does accuracy and resolution interact? For example, would someone be able to print something at 50 microns thick in a 9mm square?
Yes. So one of our Micro Plus HDs, that will be able to print probably at 30 microns in a, what is it, millimeter cube?
Yes.
Yep.
This says 9mm square.
Yep.
Would be no problem.
Not a problem.
Another question asking about the ventilation. Is there any ventilation that's necessary, or which machines would require a proper ventilation?
The desktop machines, as you see, I mean, desktops are in the house, no ventilation required. As you have more material, a separate room is recommended. Some people don't have ventilation. Some people do. It's up to where the machine is. If it's in a ventilated room, that's better. There is a bit of an odor that comes off the machine for the resin, but some places it's really user dependent.
Okay. Question going back to the software. Can you use Magix, or do you have to use EnvisionTech's software?
So you can use Magix to support and get the file ready, and then it has to be run through our slicing software for Factory Suite, which is Magix based.
Gotcha. Can multiple materials be used in building one structure? For example, one material for the center and another material that would surround that.
That can be done on the bioplotter. That requires 2 STL files that are nested. Very easy to do on the bioplotter. On other technologies, no.
And the other interesting thing about the bioplotter is that you can print in interesting materials such as metals and ceramics. It's a very versatile machine. Next question, can the printers be open sourced?
Yes, that's possible.
All right. So that was a good Q&A session. So at this time, I think what we'll do is we'll pass everything over to Bruce so he can give us a demo of the software and the system itself.
All right, Rob, can you hear me?
I can hear you, and I can see your whatchamacallit, I can see the video stream.
Okay.
Of the.
Someone will have to take me presenter.
I might be able to do that. You are now the presenter.
All right. So hopefully you can see both my screen and my web camera.
And if you toggle the bar in the middle, you can make one screen bigger over the other based on your preference.
So before I go into the software demo, I kind of just want to talk about the machine itself. What we're looking in the web camera is an EnvisionTech Micro XL, which is one of the DLP machines that they sell. The machine is fairly compact and has a hood that I can raise. This hood will keep ultraviolet light out of the material. The operation of this machine, the only moving part on it is the build tray that simply raises and lowers. And you remove it, at least on this machine, by unscrewing the thumb screw, and the build tray comes off. Now the printer builds upside down. The size of this build tray Micro XL is about 60 by 40 millimeters. The light source for the machine is held in the bottom of the unit, and it's projected upwards. If I take off this, what's called PSA assembly, there's a piece of glass in the bottom that the light is projected up through, and then the PSA is really the back that holds the two pieces to the PSA assembly. And I'm going to take off the one piece. So there's a basement portion, that's another piece of glass. And then there's the what's called the PSA itself, which I'm holding in my hand. This basically stands for a pre-stretched assembly. And there's a very taut piece of plastic stretched across the bottom of it that's clear that allows the image projected up through it. Okay. There's also a separation film which helps separate the part from the plastic. So I'll just carefully slide that back on. Now, normally these two parts would be held together with 4 screws. I took them off for demonstration purposes. Okay. If I go and pick something to open, notice I just turned on the display of an image. So the image that is going to be printed is projected upward. There would actually be liquid plastic in this PSA, and the build tray would be lowered to so there would be just a thin film of material between the bottom of the PSA and the build plate. It would get exposed for so many seconds, and then the build tray moves up and down for the next layer. So lots of times I joke that watching a traditional fuse deposition modeler printer is sort of like watching grass grow. Watching one of these in operations is like watching paint dry, because there's not a lot of action, but over time you get a very precise and high resolution image. The high resolution again is accomplished through because the only motion is up and down. You can build a very accurate linear slide, and there's no movement in the XY, which is one of the big reasons. Not only that, you have the resolution of the DLP chip projecting upwards into a fairly small area. So that basically covers the machine. The machine is can be controlled entirely offline through the control panel. Let me adjust that. You can't see it very well. I'll kind of cover it in a minute or two on the screen sharing, but you can control it via the control panel. my machine here is hooked up to wireless, so we can also control it via wireless. All right, at this point, let me just unload. I'll move over to my screen sharing, and because the machine is connected via wireless, you can also control the machine via a VNC connection to the printer itself. So here we're actually seeing the main screen. Okay, if I wanted to start printing a job, I'd simply say load job, pick some part that I might want to print. Okay, it would run through the set of images that it was going to project, and then I can hit the open button here. And assuming that I had the printer home where it was supposed to go, I would just hit the start button. Now I'm going to assume now that the build plate is up in space somewhere. I'm just going to keep it there, so the printer doesn't really know that there's no material in the bed. So now it's starting to expose each image. We see that there's 1,818 layers. After a certain amount, I'll get an estimated time, and it basically is just going to slowly move up and down. If I rearrange my web camera, you can probably barely see that build platform moving. So that's probably in a nutshell how the printer works. Let me collapse this. And let's look at the software that's used to generate a job for the printer. And to do that, I use what's referred to as the factory RP software. And what I've done is I've generated a build platform for my particular printer and for the material that I might want to use to print with. And basically, the build platform is roughly 65 by 40 millimeters on the Micro XL. So to bring in a part, I'm going to just use the file open here, and I'm going to use a Lego-like part. Everyone knows what a Lego looks like, so I'll just open this. And basically, it requires that you have an STL file. It shows you the part on the platform. I can rotate it around so that it's, let's change it to rotate it 9 degrees about the x-axis, which takes it there. If I go into this view, I could actually drag it to put it positioned on the build plate. One of the nice things about these printers is that it doesn't really matter how many parts you're printing, since it's the entire layer at one time. You can put the build plate with as many parts as you'd like. So I'll take this part. I'll first position it maybe above the build plate, about 4 millimeters. In which case it's going to use support material, and I'll use the basically just the support material generator that's built into the software. As Peter said, there is the Magic software, which you can also, if you have, generate additional supports. But I'll just pick some support combination, hit the start, and basically there are the supports. The supports are generally columns that are tapered where they touch the part, and by adjusting the size of this tapered region, they generally rip off the part fairly easily. All right, assuming that I'm happy with that, I'm just going to close out of it. Let's go back into this top view. And now here, if I wanted to, again, I'm going to now replicate this. So I'll just say I want 2 in either direction. In the X, I'll say I want 2 millimeters spacing in both X and Y. 2 by 2. Oops, it looks like they may not fit, so I might have to, I guess I can only get, print 2 of them at a time. So I'll just delete these. All right, if I was happy with this, I could then grab all of them, and then under the build, file build, give it a location where I want to build these things on, which is my documents, micro jobs, go, put them in here. So now it's basically slicing, dicing the parts that I want to build. It's basically generating the images in about maybe 10, 15, 20 seconds. We'll actually be able to go and examine the actual images that it's going to use to build this part. Yeah, almost done there. So this is being done in real time, so that's why the kind of the slowdown here, maybe. Great, we're done. At this point, I'll just collapse out of this and open up the factory start. And there's a option here for the job, which I can then open up and look for the job file. So if I have it in Documents, Micro Jobs, under Lego. So here's the job, and if I just start clicking over on the left is a list of the different layers. So initially I just have the support material, and let's just zoom that up a little bit. And at some point through the build, I'll start, now this is the real part, and so it's just going to expose this part layer by layer until maybe I get up to where the nubs are. Well, that's the top face of the Lego block. And there's the start of the nubs. And here's a nub with a 3HTI emblem. At this point, since this build file is correct, I could then, open up a Windows Explorer. I could go and find where my build jobs are under here under the micro. Here's the Lego directory I just created. And then under my computer, I could go, since the printer is connected via wireless, I can click on my job icon here. Now it's taking a few seconds here to kind of go through that. But I could then manually drag and drop the build directory onto the printer, and then via the VNC software, pick up the build job and start printing it. Once the print is done, you basically take the job off the build table. Because it is UV curable, you do have to, you first wash the part within in isopropyl alcohol. Once you wash it, it then goes into a curing station to fully cure the part. Coming off the printer, the material is only cured to about 70 to 80% of its what it needs to be cured by. So putting it into the light box when you're all done finishes curing. So I believe that kind of, and now I lost the connection to the machine. So. All right, so that, why don't we just open up the floor for questions, Rob?
Sure, nice job, Bruce.
Thank you.
Yeah, so I think this was a very good and valuable overview of the EnvisionTech product line and its capabilities, and basically how the machine works, as well as getting a STL file prepped for print. So if anybody has any more questions after the webinar, feel free to reach us at info, I-N-F-O, at 3hti.com. And we will definitely respond to your question very quickly. If you don't remember that, one thing you can remember is just respond or hit reply to any of the emails that you've received concerning this webinar. They will come directly to me. One question just came in. Are there user interfaces common throughout the product lines? So I think that'd be a question for Peter. Are the interfaces common throughout all the EnvisionTech printers?
Yes, the same software works on every printer.
Excellent. Another question, how many times can you use the separation film before needing a new film?
I'd say 80 to 100.
Yep, that's the PSA unit has to be replaced. The top unit with the transparent bottom. Right.
All right, good deal. Well, Bruce, Gary, thank you both for being on today. And also I want to thank Peter Denmark, our special guest, for giving us such an in-depth overview. Once again, thank you for attending. This is going to conclude our webinar. Have a great day and have a happy Thanksgiving. Take care, everybody.
All right. Thanks, everybody. Bye.